Good morning, good afternoon, and good evening. My name is Brian Foster. I'm a content director here at PingCAP, and I'll be your MC for today's event. In today's webinar, Shen, Technology Evangelist at PingCAP, compares MariaDB with TiDB. He'll walk through the architecture of both databases, uncover the advantages of deploying with TiDB instead of MariaDB, and explain how TiDB can serve as a more powerful, practical MySQL alternative for extreme horizontal scalability and high-performance analytics. Shen is an expert in distributed systems, relational databases, and cloud computing. He has worked at PingCAP for 7 years and is a core maintainer of TiDB. Before we get started, please feel free to drop your questions directly into the chat window. We'll be sure to answer them during the Q&A portion at the end of the talk. And with that, I'd like to hand it over to Shen. Shen, the floor is yours.
Thanks, Brian. Let's get started. Today I'll talk about MariaDB and TiDB. So the agenda will look like this. First, we're going to go through the whole MySQL world and see the different options there. And MariaDB is one of the special one in those options because it's founded by the MySQL creator. And we will go through why people choose MariaDB and what is benefit and limitation of this product. And in the last part, we will talk about TiDB and why TiDB is a better choice in some scenarios. First thing, MySQL. Both MariaDB and TiDB are in the MySQL family. MySQL has a quite long history. It's quite successful product. It started in 1994, and in the past almost 30 years, there's a lot of innovations there and a lot of good release, powered a lot of success product and services. And MySQL started with open source project, and it's belong to Oracle. Oracle acquired some system in 2009, and after Oracle acquired MySQL, there's still some major release there, like 5.5, 4.7, and version 8. A lot of new features are delivered in those releases. From DB Engine ranking, you can see MySQL is one of the most popular one. It's ranked at number 2 in the whole ranking. It's we can say that it's one of the most popular database in the world. And beside MySQL itself, there are some more options in this landscape. You can see for the database kernel itself, there's MySQL, MariaDB, Pacona Server, and just RDS from cloud vendors. And about the kernel, there's some sharding middleware solutions like Vitesse, MaxScale, ProxySQL, and others. And on public cloud, there are many options provides the MySQL as a service, like PlanScale, SkySQL, RDS from cloud vendor. And there's a special category here. We call it distributed SQL databases. For MySQL compatible database, here we have TiDB and the single store. The two products are built from ground up, compatible with MySQL protocol and its index. So here you can see the whole picture of the MySQL land and the major players here. And you may wonder why there's so many options beside MySQL. Actually, MySQL is quite successful, but there's also some limitations and pain point with MySQL. So that's why there's other options. I think the first one is the concern about the open source commitment from Oracle. After MySQL is acquired by Sun and Oracle, the community is concerned whether Oracle will keep it open source and whether Oracle will keep continuing invest in this product. So that's why MariaDB was born, and right after Sun is acquired by Oracle. Yeah, so people want open source one, have the long-term commitment. That's the first one. The second one is lack of features. MySQL is good, but there's still some some features are missed in this product in quite a long time, like instant DDL, like parallel query, and like JSON Gs is added into the MySQL quite late. The next one will be the scalability. MySQL is a single node database, and it can leverage. It can only use the resources like CPU, memory, this on single machine. So if the data volume or the traffic exceeds the limitation of single node, there may be issue. So that's why there's like sharding middleware to solve those kind of issue. Yeah. And last one is the architecture itself. MySQL is here for almost 30 years. Some of the limitation here is caused by the architecture itself. For example, the scalability. It's not very easy to fix those issues. Yeah, so I think those are the major concern about MySQL, and that's why there's options besides MySQL itself. Among those options, MariaDB is kind of special. It's built by MySQL author Monty, and it's one of the most famous option and it's quite popular. There's a couple of benefits in MariaDB. People choose MariaDB because of those reasons. So first one is advanced features. MariaDB has features like instant DDL, parallel execution engine in quite early stage. Those features are required by a developer or DBA. They are quite useful. MySQL have those features later than MariaDB. Yeah, so there are some more advanced features and more innovations there. The second one is better performance. The default setting of MariaDB are more fine-tuned for performance. Yeah, you can get quite decent performance with default setting. That's good for a developer. They do not need to spend much effort on this part, and MariaDB can handle more simultaneous connections and transactions than MySQL. So that means it can support your business growth better. Yeah, and next one is community-driven development. Yeah, I think that's one of the most attracting points for MariaDB. That's also one of the major concern for MySQL. Yeah, so MariaDB accept the contribution or the innovation from community more eagerly than MySQL. So that's why you can see those advanced features like instant DDL are first in MariaDB than MySQL. Yeah, so you can get more innovation in a community-driven product. Yeah, and last thing is MariaDB has comprehensive enterprise offering from kernel to middleware to the managed service. I will go through a little bit in the next page. Yeah, yeah. So here's the major product offering from MariaDB. MariaDB server, it's a depth kernel. It's a variety of MySQL. Yeah, but it has more features than MySQL. And the max scale is sharding middleware, and it can solve the scalability issue. It can shard the data and distribute it, and spread data into multiple machines. Yeah, so that can support higher QPS or larger data volume. Next one is column store. I think in the modern application, the workload is like complex than the legacy ones. So so sometimes people the developer need a product, a solution can handle more complex workload. So I think that's why column store is here. It stores data in the columnar format, and it's suitable for the analytical workload. Yeah, that's offering from MariaDB to solve those issues. Yeah. The last one is Scalability. It's managed MariaDB service on public clouds. So the developer do not need to maintain the database by themselves. It's easy to use. Yeah. But there are still some limitations of MariaDB. Some of the limitations are similar or the same with MySQL. Yeah. First one is still the scalability. MariaDB server, the database kernel, a single node. For a single node, it cannot scale to multiple nodes. And max scale, the sharding middleware, it can scale, but sharding is not a perfect solution for scale. It has limitation. You need to modify your application. Spend effort there. It will slow down your development. And it also has the issues of like the cross-shard consistency or not easy to do the cross-shard query. So there's limitation there. Yeah, but it can fit some scenario, but not for all. Yeah, and last one, scalability is not only about data volume or QPS. Yeah, there's more things there. For example, if you shard the database, how about the hotspot issue? Can you do the workload auto balancing? Yeah, and how can you do like a backup or restore on a large cluster? So actually, scalability is more complex than that. The next one is reliability. Yeah. Since MariaDB is MariaDB server is still single node database, so there's no built-in solution for that. You need to set up your own high availability solution, like primary secondary replication. But those solution has some drawbacks. For example, for the primary secondary replication, there's concern about the consistency between the primary and the secondary, and also for the for if there's an instance, there may be a chance that you may lose your data. Yeah, and for some complex scenarios like split brain, it cannot handle quite properly. Yeah, so there's no built-in solution. So there's some workaround or third-party solution, but they're not perfect. Yeah. The next one is limited analytical processing capabilities. Yeah. Even though MariaDB has a column store for analytical workload, but this has some limitation. It's still a single node solution. It's bounded by the CPU and the memory resources on that single machine. Yeah, it's not easy to scale to multiple machines or cluster. Yeah. So, for an analytical workload, some of them are quite heavy, need to process large amount of data, and the query may be complex. Yeah. So that's the first one. The second thing is the complex architecture. To use this technology, the column store, you need to set up a separate component and do the replication from the row store to the column store. And for the application side, it needs to access two endpoints. So this setup bring more complexity to the application architecture. It's not very easy to use. I think those the last one is still the architecture, same with MySQL, because MariaDB is built based on MySQL code base and has the same architecture with MySQL. So those kind of of limitations are not easy to solve with those architecture. Yeah, so that's some of the pain point of MariaDB. Yeah, and yeah, I want to introduce TiDB here, and for those pain points of MySQL and the MariaDB I mentioned before, most of them can be addressed by this product, TiDB. Yeah, TiDB is the most advanced open source distributed SQL database. It's built for the modern application. It has the values of scalable, versatile, and reliable. It's already used by a lot of companies and also some quite famous companies here. Yeah, it's an open source project. You can see we have a lot of stars and attentions there in the open source community. Here is a high level architecture of TiDB. Yeah, basically TiDB is a MySQL compatible database. So for application, from the application point of view, it can speak to TiDB with MySQL protocol, with your familiar driver or clients or OIM. Yeah, so for the application or the web developer, you can see TiDB as another kind of scalable MySQL. So if your application if you want to migrate your application to TiDB, which your application is already on MySQL, it's very easy. Yeah. The API or the protocol is the same thing with MySQL, but the whole architecture and the implementation is brand new, and we built everything from ground up. So it has a more advanced architecture. Yeah. The second thing here, you can see the whole architecture has a disaggregated storage and computing design. So in the middle side, the TiDB node, it's a SQL layer. It handles the protocol, the query, the optimization, and drive the whole execution. It's data SQL computing layer. On the right side is the storage cluster, storage layer. It's a distributed transactional key value storage, and it can provide scalability and reliability by nature. Yeah, and on the top is we call it PD, stands for placement driver. It's a metadata storage for the cluster, and also take charge of the scheduling of the data placement. Yeah. So the whole you can see the whole architecture is designed for scale and has a built-in reliability. Yeah. More detail here. First, how TiDB provides scalability. In one word, the data is auto sharded and spread in the cluster. Yeah, I call it sharded. Just want to let you know we will split the data automatically, but the split or the shard is totally transparent to the application. And in TiDB, we will encode the SQL data, the schema, the rows, the index into key value pairs, and the store engine will split and spread the data automatically. So you do not need to care about that. We will handle everything for you, and the data will spread among the nodes in the storage cluster. And for the data itself, we use Raft to do the replication. For a single piece of data, we will have multiple replicas, so we can provide the availability if there is single node failure, and Raft can provide the strong consistency replication. Yeah, and TiDB also provides even though we split and spread data among the nodes, TiDB can provide the distributed transaction. So the application do not need to care about or know anything about the distribution. we provide ACID transaction for application that's easy to use, and the cluster can also handle the workload balancing. The component PD I mentioned in the previous page will monitoring and do the scheduling on behalf of the DBA. So the DBA do not need to do the manual resharding or balancing. So we will handle it for you. And here's a real world use case of TiDB. You can see in this cluster there's around 200 nodes, storage nodes, and the data volume is more than 500 terabytes. The total storage capacity is more than 800 terabytes. Right now, this cluster is larger. It's much larger than this screenshot. Yeah. So actually, in the real world, in the production use cases, we have seen many clusters with hundreds of types of data run quite stable in production. Yeah, it solves the growth or the scalability issue quite well for developer. And I mentioned that TiDB designed for scalability and reliability. For reliability, the essential part here is that first, TiDB can do the replication with strong consistency. We leverage the modern replication protocol wrap to do the replication among the nodes, and for so it can work quite well and can handle the scenarios like the split brain, and it can guarantee the data consistency. And the second thing is that even though we replicate data into multiple copies, place it into different nodes, there's a chance that node fail. So TiDB can handle those scenarios automatically. We can repair those failure. Yeah. For short-term failure, TiDB use wrapped to choose a new leader for that piece of data that made issue. So the traffic will direct to the new leader automatically and provide the service, keep the application running. If the failure is a long-term failure, by default the threshold is 30 minutes. TiDB will automatically rebalance the replicas, leveraging the live nodes to rebuild replica. So then it can still guarantee the replicate numbers, rep factors. So with that two core features, TiDB can handle the failures automatically. Yeah. Yeah. Actually, I previously I talked about the architecture of TiDB. That's a simple one. You can see the SQL node, the storage node. For those, that's the architecture of the TiDB kernel, or also the dedicated tier offering on our TiDB cloud. And we are working on next generation architecture of TiDB. And this architecture is already used by our service offering on cloud. It has a more advanced architecture that is true cloud native architecture. Here's architecture of the service tier. It's complex, but you can only focus on a few things here. In this architecture, you can see we still have the SQL node, the SQL layer TiDB, and the storage layer TiKV and TiFlash. One thing here is that the whole architecture is a multi-tenant, has a multi-tenant design. You can see here that for each tenant we have the SQL node for each tenant, and a lot of tenants will share the same storage cluster. So so we can reuse some of the resource here. And for the storage layer, in the previous architecture, you can see the TiDB, the storage node, is built on local storage, like local storage or EBS. But here, the underlying storage of the storage node is object storage, like S3 or GCS. Yeah. So we have this new architecture. Then our storage node can leverage the advantage of those cloud services. It can, S3 has a higher availability and durability than EBS, and so we can put our code data on S3 and keep the whole data in TiDB. So TiDB is like a caching layer for the data. So in this way, I mean the multi-tenant architecture and also leverages the object storage. We can build a service shared by multiple tenants and has much lower cost for each tenant, and also provides more elasticity and also better durability than the previous architecture. And on the right side, you can see it's a shared resource pool for each tenant. It can allocate. It can require more resources on demand. So that means if the workload is low, we can release some of the resources, even scale to 0. But if there's a more traffic so there's a growth of your QPS, it can require more resources on demand. So compared with previous architecture, this architecture can scale to can scale out, and scale up quite well. It can also scale to 0, which can reduce cost dramatically. Yeah. On the bottom layer, you can see here is some shared services like DDL, like compaction, like data importing. Yeah. So previously, for each TiDB cluster, we need to reserve some resources for those kind of background computing. Yeah. But actually, those background computing or background jobs have different requirements than the front job traffic from the application. Yeah. So in this architecture, we have shared services for those background jobs. It can reduce cost dramatically, and it can also provide better service for those kind of jobs. For example, if we want to indexing a large table, add an index on a large table, yeah, previously you need to consume some of the resources in the cluster, and it can affect the online traffic because it consumes resource. It need to read data and insert data into the storage engine. You may be conservative to allocate more resources to this job because you care more about your online traffic. Yeah. But in this architecture, since those services are shared among multiple tenants, you can allocate more resources than before to make the indexing faster, and it has very little impact on to the online traffic. Yeah. So in short, with this brand new architecture, we can achieve better performance, lower cost, and higher durability. Which is this is more advanced architecture. Yeah. Yeah. So people, our user choose TiDB according to those reasons. First one is still MySQL compatibility. Yeah, MySQL is popular, and you are familiar with your ORM, your client, and you do not want to modify a lot in your application. So TiDB is highly compatible with MySQL. It's very easy to migrate from the existing either MySQL or MariaDB to TiDB. We provide comprehensive tools to do that. And the second reason is advanced architecture. I talked about two architectures previously. One is the current architecture. The next one is the serverless architecture under development. Though you can see those two architectures are more advanced than the legacy single node databases. Yeah. The next reason is the built-in scalability. It's very easy to scale a MySQL cluster or both scale out and scale in. You can add node or remove node according to your workload. Yeah, for example, for some e-commerce company, before the big campaign like Black Friday, you can add more nodes to the cluster to scale out, and you do not need to pause your application to do that. TiDB can handle everything for you, and it has very little impact to the production. Yeah, and after the campaign, you can just remove some node from the cluster without shut down the cluster or do the resharding. Yeah, so it can scale elastically. Yeah, and and TiDB provide is quite stable at large scale. As I mentioned before, scalability is not only about the data volume or the QPS. It's much complex than that, and we have a lot of production use cases, and we learn about a lot from those cases, and we put a lot of effort to make it stable and perform at a large scale. Yeah. And TiDB has a higher performance analytics capability than single node MySQL or MariaDB column store. I mentioned the TiFetch node in the previous page. It is a column store engine. It can replicate data from the row store TiKV to column store. Then our planner, the SQL layer, will decide which store to use. That decision is transparent to the application. So the application do not need to know there is column store there, and we provide the consistency between the row and the column store. So there's no consistency issue there. That's peace of mind for the developer. Yeah. So TiDB can provide better performance and has a simplified architecture for the hybrid workload. Yeah. The last one I think is active open source community. Yeah. TiDB is here for more than 8 years, but there's still a lot of motions in the open source community. You can see a lot of features added by PingCAP or the contributor from from the community. Yeah. And TiDB, we use the Apache 2 license, which is more community friendly. Yeah. So we already talked about MariaDB and the TiDB. So here we do a comparison between the offerings from both sides. For MariaDB, there's a MariaDB server, and it's similar with TiDB. Provides similar like the functionality or capability. It's both are MySQL alternatives, and MariaDB has a max scale, the middleware, to scale the data volume or QPS, and TiDB has built-in capability to scale out or in elastically. It can scale to a large scale, and it's easier to use than middleware, sharding middleware. And MariaDB has the column store for the analytical workload. TiDB has a TiFetch component. It's a columnar extension. It has better performance and easier to use compared with the column store. And MariaDB has the SkySQL, the managed offering on cloud. TiDB has we have TiDB Cloud, which is data as a service. TiDB dedicated tier is like equivalent of the SkySQL. And besides dedicated here, we have the service offering now. The architecture, as I mentioned before, it's very easy to use and with much lower cost. And you may wonder what is the path or the way to migrate. Yeah, you already seen the advantage of TiDB. You may wonder how can I try it if I have application running on MariaDB or MySQL. How can I migrate to TiDB? It's very easy. Yeah. So we provide a bunch of tools to help you to do that. Yeah. It depends on which tool to use. Depends on the data volume you want to migrate. If for a small cluster, like the data volume is more than 500 gigabytes, it's very easy. You can just use our tool called DM to do the migration from the initial data loading to the incremental data migration. DM will act as a secondary of MySQL. It can read the MySQL or MariaDB log and replicate the bin log into TiDB. So it's very easy to use. It can even merge a sharded MySQL or MariaDB cluster into one TiDB cluster into one table. Yeah. If the data volume is large, for example, larger than like 500 gigabyte, if you care about the speed, you want to do it very fast. For example, I have seen some product use cases that our customer migrate like more than 1 terabyte or even a few tens of terabytes data from MariaDB, from MySQL, MariaDB, or other data sources into TiDB. They want to do the data ingestion very quick. So we provide a tool called TiDB Lightning. From the name, you can tell it's built for speed. You can dump the data from the data source into local disk or object storage like S3. Then our TiDB Lightning will read the data there and convert it into the underlying data format in our storage layer and just ingest those data into our storage. So that can be much faster than TiDB DM for the initial data loading. And then you can set up the incremental data loading pipeline, replicate the bin log from the upstream to TiDB. Yeah. So in this way, you can do the data migration very easily. Yeah. Okay. That's all today for my sharing. And besides, if you want to hear more about TiDB's knowledge and the use case of TiDB in some famous companies like Databricks, Pinterest, Airbnb, feel free to join our HTAP Summit next month in Mountain View. Yeah. Thanks.
Excellent. Well, thanks, Shen, for this great presentation. Now let's see if we have any questions from our audience. Okay, have one here. So sharding has become somewhat of an industry standard for scaling databases. Why should companies move away from sharded MariaDB to an auto-scaling distributed database like TiDB?
Yeah, that's a great question. Yeah, actually, sharding is quite a mature technology used for quite a long time, and a lot of companies are still using sharding. It can solve some of the issues. It can scale to quite a large data volume, but sharding, as I mentioned, sharding has its limitations. First, it need to modify the application. Has burden to both the developer and the DBA. it also have the issues of the like the consistency between the shards, and also limit some queries that need data across multiple shards. Yeah. So and the last thing is that it's painful to do the resharding. Yeah, you need to double the shards if you want to do resharding. It requires a lot of resources there, and you need the effort from both developer and DBA to do the resharding. I think the last thing is it's not easy to handle the hot shard. Yeah, your workload may be not perfect distributed among the shards. There's maybe one shard quite hot. It can slow down the whole system. So that's things in my mind about sharding.
No, that's a great answer. Really interesting to kind of think about it that way. All right, let's check our list, see what else we have kind of coming in. Yeah. Are there any specific application workloads that are a better fit for TiDB compared to MariaDB?
Yeah, I think the workload for the workload wise, first one is if your application your workload is like the fast growing, you want a better solution to support that growth. TiDB is better. It can scale elastically. You can add node and remove node at any time, and that's first one. The second one is that you have like a your workload is like for some modern application, as I mentioned. For example, for a SaaS service in the backend, there is not only simple point get or insert, but there's also like some dashboard for your customer to see the real-time data. It's not easy to set up like a ETL pipeline between the relational operational database and the data warehouses and build a complex application on top of that architecture. TiDB has a more advanced architecture, has a distributed computing framework, the smart optimizer, the column storage, those bunch of things can support those kind of modern workload. Yeah.
Excellent. No, that's a really interesting answer. Yeah. Let's see what else we have in the list. Okay. You mentioned two cloud database as a service offerings of TiDB.
Yeah.
What makes these offerings unique compared to, say, MariaDB's SkySQL offering or even MariaDB's serverless offering?
Yeah, good to know that there's a service offering there on SkySQL, MariaDB SkySQL, and I talk about two architecture of TiDB. You can see the architecture for the current database kernel, and that's also for the dedicated tier, and a brand new architecture for the service tier. Yeah, our view is that for cloud native database or the service or the service offering, the elasticity is quite very important. You can see for our new architecture, the shared resource pool, leverage S3, and the separated code data and hot data. Those bunch of innovation provide quite good support for our service tier to scale to quite large scale and also scale to zero in quite short time. Yeah. So we leverage. I think the TiDB service architecture is a true architecture, cloud native architecture, leverages the promise from cloud, the elasticity and resilience from cloud, and with those innovation, I think we have more advanced architecture can provide a better product, and the whole cost of our single tenant and service tiers is super low. Yeah.
Gotcha. No, that's a great answer. Thanks for kind of diving into those comparisons. Let's see what else we have from the question list. Okay. Slightly unrelated, but I think an interesting question. What type of security features and enhancements come built into TiDB?
Yeah, so we have a bunch of security features, and also we have some compliance like SOC 2, like PCI, GDPR. Yeah, for the security features, we have like for the network, for the connection, we have private link, VPN peering. For the kernel, we have audio log. We have the RBAC. For the encryption, we have the both encryption in flight and at rest. Customer can manage their encryption keys by themselves, and we also have the integration with some like popular authentication service like Okta. So I think for TiDB, we have quite comprehensive security features that can meet the requirement from the enterprises.
Excellent. No, that's a great answer, and it's great to see again kind of the breadth and depth of different compliances and certifications that TiDB has. I think it's a really really important aspect of the technology. Let me go back into the questions here, see if we have anything else to kind of go through.
Yeah, actually, regarding the service offering, I want to share a little bit more.
Sure.
Actually, we have own service called OS Insight, which is the which is the data analytics service on top of the open source data we grab from GitHub. Yeah, so that service is built on our service offering. Yeah, so we migrate that from our dedicated tier to service tier, and with service tier, we reduce cost dramatically. It has only like 30% of the cost compared with the dedicated tier. And what's besides cost? There's one day there's a lot of traffic to our OS Insight service, the website. Yeah, because it went to the front page of Hack News, so a lot of traffic there. But our service scale automatically add more resource, more node for OS Insight, and it handle 10 times larger traffic than normal without any issue. And after the traffic spike, the service TiDB for OS Insight scale in automatically, save cost. So that's so you can see we do not need DBA to interfere in this process to handle the traffic spike.
Excellent. Yeah, no, that again, it's a great kind of use case of TiDB serverless and how it actually can work in a pretty powerful way. No, so thanks for sharing that. Let's take a look and see if we have any other final questions that are kind of from the audience here. Let me. I think we are good for right now. So again, I want to thank everyone on the webinar for attending. Again, it was a really great talk. As we mentioned, we'll be sure to make a recording available to everyone who registered for the event in the coming days. So stay tuned for that if you'd like to go through and look at anything else. And as Li Shen mentioned, again, we have our HTAP Summit coming up. So again, if you'd like to attend, feel free to scan the QR code on this slide, and we'll hope to see you there. But for that, again, I'd like to thank you all, and hope you all have a great rest of your day.